Hello, welcome to video number 4 in the pattern series. This time we want to talk about specific columns on the periodic table and shortcuts when talking about them as a group. So when chemists were working on a lot of these different things, they noticed that a lot of elements in the periodic table had similar properties, and a lot of those properties aligned per the column that they were in. So for example, all of these yellow elements have something in common. The green, all of the purple, the orange, and the blue. Now, that's not to say that the 13th through 16th columns right here don't have these things. They do. It's just they're not commonly used as much. So, for example, here on the website, you can see where it's small, but it says pictogens and chalcogens, which is 15 and 16. And again, the pnictogens end up over here as well, and and the chalcogens over here. But that's kind of because these are the big 5 that are talked about the most. And that's a lot because of reactivity and a lot because of unreactivity, which is special about here. So this video is just to go over kind of where they are. There's no really trick to this. You just need to kind of start to understand that all the alkali metals, alkali stands for base. So these are basic metals, and they all have similar properties. Hydrogen is not a metal. Hydrogen is a gas, which is why I color-coded it a little bit different here in red. All of these are the alkali earth metals, also basic, but all of these have something in common. The transition metals are all in purple here, and again, they are called that because they transition from, again, you can see the high parts here to the secondary high parts here, called the transition metals, and these have similar properties. And then the 17th, halogens, and again, the noble gases. Again, this is color-coded all for you at the top right here. Some things that they have in common. This will be a whole video on its own very, very soon. But one of the big things about this is the charges and the valence electrons. So just to kind of fast forward a little bit, everything in this column has a +1 charge. They are going to lose an electron to become stable. This entire column, and that is a very poorly drawn 2. I apologize for that. +2. Every single one of these wants to lose 2 electrons to become stable, and they will do things in order to do that. The transition metals, this whole area here, all these guys are positive, but we actually don't know how positive. And that's actually the special thing about the transition metals. They have a different amount of valence electrons. So what does that mean? Watch the next video to find out. But they're all positive. We can at least talk about that. Going through here, these are all +3. These are all plus or minus 4. What's up with that? We just went +1, +2, +3, +4, and now we're switching? We are switching. And that has to do with the octet rule, which will be on the next video. And I'm just finishing off the pattern with the charges. And again, this is all based on valence electrons, which we'll talk about. But that is one of the things that's really special about them. And again, along with this charge becomes reactivity. -1 and +1 are super reactive. They are 1 electron loss away from being stable or 1 electron gained from being stable. So just want to do a short little video on that. Again, all you kind of need to know is what each column is called. Column 1, except hydrogen, alkali metals. Column 2, alkali earth metals, transition metals, halogens, and the noble gases. See you guys in the next one.